Bismillahirrahmanirrahim. Assalamu alaikum. Welcome to my YouTube channel, Science for Everyone. Today I have brought a very important topic for you people. And the title of the topic is the adenosine triphosphate and the secrets behind it. And the main question that I will discuss in this video is that how ATP is formed, how it gives energy, and where does the energy come from inside the ATP. Basically, in the earlier classes, we were taught that the general structure of ATP, and we were taught that it is the energy currency of the cell, and it when the bonds that are present in between the phosphate bonds, when they are broken down, so it gives us energy, and that energy is used for in different metabolic processes. But question come in mind that how is this energy stored in that bond? Either that bonds contain energy or not, and what is the molecular level of this ATP? That how this energy is transferred to molecules and different other questions that are related to ATP. And I'm pretty sure that most of the students are thinking about it, and I think they have found the answers to it, but there are more students that are not knowing about this. So because of it, I have made a video over it, and I want to tell you guys that please watch this video till end, so that you should be clear about the molecular level of ATP and the secrets behind it and how is energy formed and all other things. Okay, so let's start with the video. First of all, this is a general structure of ATP, and I think you all are familiar with it. It contains an adenine base and a ribose sugar and three phosphates. This is an adenosine triphosphate. Okay. First of all, we were taught in the earlier classes that this bond, this curved bond, contains high content of energy, that is mainly 7.3 kilocalories, and when this is broken down, so energy is given, energy is produced. But here I want to tell you guys that this is not the case. Basically these bonds contain these does not contain the energy. If I clear the diagram, okay, now I will tell you that what is really behind this, where is this energy. Okay, so just look here, these are the oxygen elements. These are the oxygen elements that are present in the that are linked to the phosphate. Okay, so as you know that in a oxygen contains electrons. Okay, unpaired electrons, sorry, paired electrons, just look here. Okay, these contains electrons, and just look here, or some oxygen contain two electrons or some contain one electron when these are bonded to the hydrogen atom. So just look here, here is a very high density of electron. Okay, if we look to this molecules, there is a very high density of electron, and as I have as you know that same charges repel each other. If there is high content of negative electrons, so these will repel each other. But here, what is the case here? These either these electrons repel each other, but they are strongly attached to each other. I want to tell you guys again that here is a high density of electron, and here is a very repulsion forces in between them, but they are still bonded to each other. Okay, so when there is a water molecule, when there is a water molecule, so if there is a water molecule, so this ATP want to give its phosphate to the water molecule. Just look here, if here is a phosphate, okay, these are the three phosphate. Okay, I am explaining it in my way. Just wait for the correct answer. These are the three phosphate, and here is the water molecule, for example. Okay, here is the water molecule. Okay, this is the water molecule. Just its structure is like this. Okay, but okay, I will draw it like this. Okay, so this is a water molecule. Just erase it. So just because of the high content of electron, this ATP wants to give its phosphate to the water molecule in order to stabilize itself because of the high content of electron. Okay, So when it is a spontaneous reaction, okay. So when it gives its phosphate to the water molecule, so it is an exergonic reaction, okay. It is an exergonic, it is spontaneous and it is exergonic. This means that it has stabilized itself, because here is a high content of electron and there is a very high repulsion force in between them, but they are still stick together. So when they find a suitable partner, so they readily give its phosphate to that molecule, okay. So when they it is a spontaneous reaction, so ATP is a high energy compound, okay. Just because of the repulsion forces, these are the high energy compound. So when they give its phosphate to the other molecule when they are of lower energy, okay. So they gives it is an exergonic reaction, okay. It is an exergonic reaction. So just because of this, when it has stabilized itself from high energy state to lower energy state, so it gives energy. As this is the same case as when as we have told in the previous classes, that for example, this is an atom, this is a nucleus, okay. This is a nucleus and this is the first shell and this is the second shell. So when the electron, okay, for example, here is an electron, and when it moves from the high energy orbit to the lower energy, lower energy shell, so it radiates energy, okay. It radiates energy because it has transferred itself from the high energy state to the lower energy state, okay. So just because of this, this is the basically the energy. So keep this thing in mind, that energy is not present in between the bonds, okay. this is this is the main case, that 7.3 kilocalories energy is stored, is radiated, okay, when the phosphate is given to the molecules that are in the lower energy state, okay. So keep this thing in mind, that whenever you see a metabolic process and ATP is converted to ADP. So for example, if I want to clear this drawing, so for example, if I this is a compound, okay, this is a compound and this is also a compound, okay. Sorry for the drawing. So and here there is a reaction that ATP, okay, ATP is converted to ADP, okay. This is the ATP and it is converted into ADP. This means that it has given its phosphate to the other compound, okay. Now here is the phosphate. So first keep this thing in mind, that it must this is not the actual case. It is giving the phosphate bond phosphate to the other molecule, but first it has to process this reaction, okay. So first it has to give its phosphate to the water. After that, it has to, this phosphate is then given to the molecule, okay. So there is a couple reaction, okay. Here is a couple reaction. So if someone asks you that ATP directly give its phosphate to the other molecule, so your answer will be no, because it must be hydrolyzed to give 7.3 kilocalories energy, okay. It should be hydrolyzed. After that, this phosphate, okay, this phosphate will be then given to the molecule, okay. So here will be a couple reaction in the metabolic processes. This reaction is not shown, just it is directly the molecule is converted into the other molecule, but it has to pass, it has to be hydrolyzed, and after that this phosphate should be given to the molecule. So keep this thing in mind, each and every process contain this, okay. Now I will discuss that. Hope you have understand this, that where does this energy come from. Again, I'm telling you, here is a high electron density, and this molecule is in a very high energy state, okay. So when it gives its phosphate to the water molecule, so this molecule is moved from the high energy state to the lower energy state, and just because of it, it radiates energy. It is an exergonic reaction, and that energy is 7.3 kilocalories, and it is also known as 30 kilojoules per mole. 7.3 kilocalories and 30 kilojoules are the same, okay. So sometimes you will see 30 kilojoules per mole, okay. So that is also same, and this is also same. Okay, so keep this concept in your mind. Now we will proceed further. Okay, phosphoryl group transfer potential. Now I will discuss that how ATP is formed and how ATP is liberates in energy and metabolic processes. Okay, so phosphoryl group transfer potential means that the measure of tendency of a compound to transfer phosphate to H2O. Okay, in the previous slide I have discussed that phosphate give its ATP give its phosphate to the H2O. Okay, so ATP is the intermediate. Okay, just look here to the colors. This is the purple color and this is the blue color. Okay, so here is the ATP is the intermediate. Okay, so when ATP give its phosphate to the water molecule and after that it is accepted by the other molecules, so it gives 30 kilojoules per mole energy. Okay, the kilojoules per mole or 7.3 kilocalories per mole. Okay, but there are some compounds that contain phosphate. Okay, and they are in a much higher energy state than ATP. Okay, again I'm telling you, as I have told you that ATP is in a very high energy state. So it is it wants to give its phosphate to the lower energy phosphate compounds. Okay, so when they give its phosphate, so energy is liberated, and that is 30 kilojoules per mole. But there are some compounds that are known as phosphoenol pyruvate, 1,3-bisphosphoglycerate, and phosphocreatine. These also contain phosphate. I will show you the molecular level of these. Okay, just look here to the concept. These contain phosphate when, and these are much higher. These have much higher energy state than the ATP. So when they give its phosphate to the ATP, okay, this phosphate to the ATP, so what will happen? It will liberate. If phosphoenol pyruvate give its phosphate to the give its phosphate to the water molecule. Okay, if it gives phosphate to the water molecule, so 60 kilojoules per mole energy will be released. Okay, I am saying again that when here is a phosphoenol pyruvate, when it is hydrolyzed, okay, and the phosphate is given to the water. Okay, again I'm telling you that water should be there. Okay, first the phosphate group should be transferred to the water. After that this phosphate will be then given to the desirable compound. Okay, so when this phosphoenol pyruvate give is hydrolyzed, so it produces minus it is an exergonic reaction, and it produces 60 kilojoules per mole energy, and that energy is used in the metabolic process, and it can also be used in the synthesis of ATP. Okay, so I will now discuss it in the later slide. Just keep this thing in mind that ATP is in the intermediate level. There are certain compounds that have a high energy state than ATP. Okay, and there are certain compounds they have a low energy state than ATP. So the ATP will give its phosphate to the lower energy compounds, and the higher energy compounds will give its phosphate to the ATP. That is, now this ATP is at lower energy with respect to these compounds. Okay, so just keep this issue in your mind. Again, I am showing you. Okay, this is another diagram. Here is the ATP. It is in the intermediate. It can give its phosphate to the glucose 6 and the glycerol because these are in the lower energy state. But it cannot give its phosphate to the phosphoenol pyruvate and these compound and this compound. Just look here why this phosphoenol pyruvate is in a very high energy state, because it contains the oxygen elements in a very high density. Just look here, these are 3 oxygen compound and they are oxygen elements. Okay, 3, and here in with respect to ATP, here is a very much high electron density. Okay, so because of this high energy electron density, these are in a much high energy compound. Okay, so what is phosphate transfer potential? Phosphate transfer potential means that the potential of a compound to give away its phosphate. Okay, so here the highest phosphate transfer potential is of the phosphoenol pyruvate, and the lowest phosphate transfer potential is of the glucose 6 phosphate. Okay, so these are known as the phosphate transfer potential. Again, I am telling you, phosphate transfer potential means the potential of a compound to give away its phosphate. Okay, so the higher the phosphate transfer potential, the more the compound is willing to give away its phosphate. Okay, so just look here. I am telling you that phosphoenol pyruvate, when it give first it is hydrolyzed, so it gives 60 kilojoules per mole energy, and this minus means that it is exergonic. Okay, so half of the energy is used in synthesizing ATP. Okay, after that, this phosphate is accepted by the ADP. Okay, and this is minus 60, so minus 30, this minus 31 is used in the synthesis of ATP. Okay, so again I'm telling you that when ATP is ADP, if just look here, this is a reaction. So this is an endergonic reaction, because as I have told you that in the previous slide. Okay, if I want to show you in the previous slide. Okay, this. So I have told you that these contain high electron density. Okay, these contain high electron density, but if there is sufficient energy, of minus 30 kilojoules per mole, so this energy uh, can bring these compounds together. Okay, this energy is used to bring these compounds together. So minus 30 kilojoules per mole energy is used to bring phosphate together. Either they are not willing to come together, but this energy makes it to come together, and this is just because it is known as the energy currency of the cell. Okay, so keep this concept in your mind. Okay, now I will proceed further. Now I will show you that how ATP dissipates its energy. Okay, so as you know that now you are clear about the phosphate transfer potential. Okay, so here is a glucose and it is converted into glucose 6 phosphate. Okay, and this phosphate is provided by the ATP. Okay, so just look here. I'm telling you that there is a couple reaction. Just look here to this reaction. First of all, there is a side reaction, and this side reaction is this. Okay, this is the side reaction. First, the ATP should be hydrolyzed. Okay, the ATP should be hydrolyzed, and after that, this phosphate should be given to the glucose. So just look here, glucose plus phosphate, glucose 6 phosphate. So it is an endergonic reaction. It require, if we want to give phosphate to the glucose, so it should be endergonic. We should have to provide the energy to attach phosphate to the glucose 6 phosphate. So what happens? The ATP hydrolyzes and it gives away 30 kilojoules per mole energy. Okay, so after that, the half of the energy, the 16.7 kilojoules per mole energy is used to attach the phosphate to the glucose, and the half energy is dissipated as heat. Okay, the half energy is dissipated as heat. So now you should know that when you eat something and when there is digestion and after that glycolysis, so you feel hot. After you eat something, so you feel hot, and these, so just because of this, there are other also reaction that creates heat. Okay, so this is the this is the first step that it create heat. Okay, so minus 16.7 kilojoules energy is used by adding phosphate to the glucose, and half of the energy is dissipated as heat. Okay, so now I'm telling you that this is an high energy state potential. Okay, this is the high phosphate transfer potential, and it is this glucose in the lower phosphate transfer potential. So it will first it will be hydrolyzed, and after that this phosphate, okay, this phosphate will be then added to the glucose, okay, and this energy will be produced, okay, this energy will be produced. So half of the energy will be used by adding phosphate to the glucose, and half of the energy will be dissipated as heat, okay. So now you are known that how ATP is used in the metabolic processes, okay. This is the consumption of ATP. And in the next slide, I will show you that how ATP is produced. Okay, so just look here. This is a phosphoenol pyruvate. Okay, phosphoenol pyruvate, and as I have told you that phosphoenol pyruvate is in a very high phosphate transfer potential with respect to ATP. Okay, so what will happen when this phosphoenol pyruvate is hydrolyzed? So minus 61.9 kilojoules per mole energy is produced. Okay, so this is a very high energy. Okay, when it is hydrolyzed, okay, when it is hydrolyzed, first it should be hydrolyzed, then the phosphate will be added to the ATP. So how this ATP is produced? First of all, the phosphoenol pyruvate will be hydrolyzed, and this energy will be produced. After that, this energy will be used, okay, this energy will be used to add this phosphate to the water, sorry, to the ATP, so ADP, okay. This energy, half of the energy, this 30 kilojoules per 0.5 kilojoules per mole, will be used to make ATP from ADP, and just because of it, this phosphate is added to the ADP. And it is the as I have told you that the formation of ATP is an endergonic reaction, and it required 30.5 kilojoules per mole energy. So half of the energy will be used to form ATP, and half of the energy will be used in other metabolic process, or it should be dissipated as heat. Okay, so this is just because that phosphoenol pyruvate has a very high phosphate transfer potential with respect to the ATP. So it will readily give its phosphate to the ADP to form ATP, and after that it will be converted into pyruvate. So now you have known that how ATP is produced, and in the previous slide you have known that how ATP is consumed. Okay, and just take a screenshot from this text. Okay, I have explained it in the earlier video. Just take a screenshot from it and also study it. Okay, again I'm telling you that again I'm telling you that the reference to ATP as a high energy molecule, just look here, does not mean that there is a great deal of there is a there is a great deal of energy stored in a particular bond. Okay, it simply indicates that the removal of terminal phosphate goes to completion with a large negative standard free energy chain, that minus 30 kilojoules. Okay, that is the large negative standard free energy. So just study this text, and you will be now, after that you will be much clear about it. And this is the remaining part of the text. Okay, so just take a screenshot, and then you will be known to it. So don't judge the duration of the video. Okay, and hope you have understand it well, that how ATP is formed and how ATP dissipates its energy. Okay, so I think you have get your answer. If you have any further questions, so you can ask me in the comment box. I will answer you there. Okay, and if you have understand in this video, so like this video, share it with your friend, and subscribe to my channel for more interesting videos related to science. Thank you very much. God bless you.